Hello everyone, welcome back to our channel. Chemistry is easy for you. The topic today we are going to discuss is for the Iit-Jee aspirants, and it is the method to find the hybridization of any atom or molecule that we are considering. We are having two methods, and the one which is convenient for you can be taken by you. I'll be discussing both the methods. So the first method is by the equation, that is H is equal to half into V plus M minus C plus A, where V stands for the valence electron of the central atom. M stands for the number of monovalent atoms attached to the central metal atom. What is monovalent atom? Monovalent means the atoms like hydrogen, chlorine, fluorine, iodine, etc., which are having valency 1. Those are called as monovalent atoms. Then C is the cation charge and A will be the anion charge. Now we will be getting a resulting number, which is H is equal to some number. If H is equal to 2, our hybridization will be Sp. If H is equal to 3, our hybridization will be Sp2. 4, it will be Sp3. 5, it will be Sp3d. 6, it will be Sp3d2. 7, it will be Sp3d3. So once again, this is the equation, that is H is equal to half into valence electrons of the central atom plus the number of monovalent atoms attached to the central atom minus the charge of cation plus the charge of the anion. If it is 2, 3, 4, 5, 6 or 7, correspondingly the hybridization will be Sp, Sp2, Sp3, Sp3d, Sp3d2 and Sp3d3. Now we will go and check some examples. The first example that we are going to consider will be CH4. Now for CH4, what will be the central atom? The central atom will be carbon. That is carbon. So the valence V is equal to the number of valence electrons of the central atom. Here number of valence electron of carbon will be equal to 4. Therefore V is equal to 4. Now M. How many monovalent atoms are attached to carbon? Hydrogen is a monovalent atom. 4 hydrogens are there. So 4 monovalent atoms are attached to carbon, and therefore our M will be also equal to 4. Now we can see CH4, the methane is not a cation or an anion. It is just a neutral molecule. So C and A will be equal to 0. Now we can substitute this in the equation and we will get H as H is equal to half into 4 plus 4. The other 2 will be 0. That is equal to half into 8, which is equal to 4. Now from the chart, corresponding to 4, our hybridization will be Sp3. So the hybridization of methane will be equal to Sp3. Next we will be considering another example which is having a charge, so that it will be more clear to you. The example that we can consider here will be NH4 plus. Okay. Here also the first thing, what will be the central atom? The central atom will be nitrogen. Now nitrogen is the central atom, means we will be having valence electron as 5, because the number of valence electrons of nitrogen is equal to 5. Now how many monovalent atoms are attached to it? 4 monovalent atoms. So M will be equal to 4. We will be having a charge here, that is cationic charge of plus 1 is present here. So C will be equal to 1. There is no A. So from the equation we will be having H is equal to half into 5 plus 4 minus 1. It will be again is equal to half into 8, which is equal to 4. Here also the hybridization will be nothing other than Sp3. Now I hope this part is very clear to you. Next we will be considering an example which is having an anionic charge. We can, for example, let us consider I3 minus. For I3 minus, the central atom will be iodine itself. So what is the valence electron of iodine? All the halogen, those will be having the valence electron 7. So here the valence electron will be equal to 7. Then how many number of monovalent atoms are attached to this? 2, because iodine is monovalent. One iodine is the central atom. The other 2 iodines will be the monovalent atoms that is attached to the central iodine. So M will be equal to 2. Here this is having an anionic charge. So C will be equal to 0 but A will be equal to 1. Now what will be our equation? It will be equal to half into H is equal to half into 7 plus 2 plus 1. So it is equal to 10 by 2 which is equal to 5. Now from the chart, what is our hybridization for 5? It is sp3d. So we have discussed three different examples, one of a neutral one having a cationic charge and the other having an anionic charge. So for all these cases, this first method is applicable and you can easily find the hybridization from this equation. Now I'll be discussing the second method also, but it will be a little confusing for some of you, so listen carefully. So now we are going to discuss the second method. So in case of the second method, we have to calculate the total number of valence electron of all the atoms, not just the central atom but all the atoms. Now consider the answer of this, that is the total number of valence electron. If it falls in the category 1 to 8, then we have to divide the answer by 2. And we will be getting any one of these number and the corresponding hybridization will be the same. The number of the hybridization to each of these number will be same, but how to find this number, that is the difference in the method. So once again we will be calculating the total number of valence electron of all the atoms, and if the answer falls in the category 1 to 8, we will divide it by 2 and correspondingly we will find the hybridization. Now as a case B, if it falls in 8 to 54, then we will be dividing it by 8. And suppose we get an answer Q1. If there is no remainder, this Q1 will be equal to any one of this number. If there is a remainder, what we have to do? We have to divide it again, but this time by 2, because it is a lesser number and we have to divide it again by 2. And suppose the answer is Q2. Now what we have to do? We have to add Q1 and Q2 and that will be any one of these number, that is 2, 3, 4, 5, 6 or 7. And then we will be having SP, SP2, SP3, SP3D or the other two. Any one of these will be the hybridization. I know this is a little confusing. I will be explaining this by using some examples. So let us consider we are having, again we will be doing with H2O here. So we are having 3 atoms here. That is 2 hydrogen and 1 oxygen. So what is the valence electron, number of valence electron of oxygen? It is 6. And since there is only 1 oxygen atom, the total valence electron will be 6 itself. The valence electron of hydrogen is equal to 1, but we are having 2 hydrogen, so the answer will be, total electrons will be 2. So 2 and 6, so the total electrons will be equal to 8. Now what we will do? According to this, it falls into the category A. Now we will be dividing 8 by 2 and our resulting answer will be 4. And what will be the hybridization? It will be sp3. Okay. This is the first one. Now we need to do an example where it will be falling in the category of the second one, that is 8 to 54. So that I can tell you about how to do the things with the remainder. So let us do that one. Consider for example, you are having C2H5OH as the question. So what are the atoms present here? C, H and O. What is the number of valence electron of carbon? It is 4. But we are having 2 carbon atoms, so the total electrons will be 8. In case of hydrogen, number of valence electron is equal to 1, but we are having total of a 6 number of hydrogen, so it will be equal to, 1 into 6 which is equal to 6. Now oxygen, the valence electron is equal to 6, but we are having only 1 oxygen, so it will be 6. Now the total number of valence electron here will be 20. So now definitely it falls in the category B. What we will do? We will be dividing 20 divided by 8. What is our answer? It will be going 2 times 16 and we are having a remainder 4. According to this, 2 will be the Q1. Now since our remainder is not 0 but instead it is 4, we will divide this 4 again by 2. Now it became 4 and we got the remainder as 0. Here 2 will be the Q2. Now we have to do Q1 plus Q2 which is equal to 4 and our hybridization will be sp3. So that is our answer. I hope you understand that we will be calculating total number of valence electron of all atoms. If it is in 1 to 8, we will be dividing it by 2, and if answer is any one of this, corresponding hybridization will occur. If it is in 8 to 54, first we will be dividing by 8. If the remainder becomes 0, then directly we can find from this. If the remainder is not 0, we will be dividing it again by 2 and we will be adding the both quotients and we will be finding the hybridization. Okay, I hope this part is clear to you. And if you have any other doubt regarding hybridization, please feel free to ask to us and we'll surely help you. Next, in the next topic, we will be discussing some previous questions from the hybridization part. And all of you please watch the previous video which I have done on VSEPR theory and the different shapes. It will be helpful because the question comes together, that is to find the hybridization as well as the shape. So you can check both of the videos together and we will be doing the questions. Also in the next video I will be doing D block elements and also their properties, color, spin only formula, all those things will be done in the next video. Thank you so much for watching. Please subscribe our channel, like all the videos and please keep commenting for whatever topics you need or any study materials you need. That's all for today. Thank you.